So as a reminder, take an exam, be sure to read the questions carefully, right? Make sure you're not doing too much. Also, if you look at this first one here, it's literally got parts A, B, C, D, E, maybe even more. There's A, B, C, D, E, which all kind of depend upon what you do. So we need to be extra kind of careful. First question here, consider these points, compute these two vectors and their cross product. So let's see. I'm going to find PQ first. The PQ is just Q minus P. So, and I don't know how much work you need to show here. I probably wouldn't do the subtraction showing the work. I would probably say, I know that -2 minus 1 is -3. And 0 minus 0 is 0. And 3 minus 0 is 3. And in a similar way, PR is going to be, well, R minus, so -5 minus 1 is -6. 1 minus 0 is 1. -1 minus 0 is negative. But you can show a little more work there if you feel like you need to. And then to do PQ cross PR, we're going to do, I'm going to write it this way, right? We've got I, J, K, and you've got PQ first. And you do, order does actually matter here when you do a cross product. I mean, it matters slightly in that if you do it the opposite direction, you will get the opposite direction vector, but it's still perpendicular to both. So here, you're -3, 0, 3, -6, 1, -1. And you do this whichever way is most comfortable for you. I personally like to do it the cofactor expansion way, where we do I times the determinant of the 2 by 2 matrix, 0, 3, 1, -1, minus, definitely remember the minus sign for J, determinant of -3, 3, -6, -1, plus K times the determinant of -3, 0, -6, 1. For those of you joining us, Caleb, we're just going over the harder, or in my opinion, the harder of the two Casal's practice exams. I don't remember whose class you're in, but if you're in Alameda's class, we're going to go do some practice exam stuff for him on Friday. And then calculating this, we should be extra careful here. We're going to get 0 minus 3. And I might write that down just so they know you know what you're doing. So you got I times 0 minus 3 minus J times 3 minus -18 plus K times -3, 6, that doesn't matter, minus 0. That ends up being -3I minus 21J minus 3K. Great. So the next question asks is really asking you to write some words. Consider the unique plane below containing the points P, Q, and R. Explain why this plane is an equation for, or this, explain why this is an equation for that plane. I would say the following. So I can see, well, this plane I has the normal vector, which is just the coefficients, -3, -21, -3. But that's exactly the vector we just came up with above, which is PQ cross PR. But that's not enough, right? Because the plane to be the plane that contains these 3 points, you have to have the right normal vector, and you also have to have a point. So we can also say, and the plane pi does contain all 3 of those points. I feel like you might not even have to say this part first, right? You could literally just actually check. You could say, well, contains the points P, Q, and R. So I'm going to say, well, clearly P is in there, right? Because 1, 0, 0 is in pi. Check. -3 times 1 minus 21 times 0 minus 3 times 0 certainly equals -3. And similarly, the other 2 points are also in there. Yeah, I feel like maybe I'm not exactly hitting on what he wants you to write, but I would say, well, we've got the right normal vector and we've got the points we need. So that's got to be the equation for the plane. Maybe there's something else he wants, but I don't know exactly what that would be. All right, definitely, if you have questions, stop me, or if you want me to explain anything more, let me know. Sure. So right, pi, this equation, this plane, we know that the normal vector of a plane is just the vector whose components are the coefficients of x, y, and z. That is a true statement. So if you know the coefficients of x, y, and z, those directly translate to those components there.
Do we know that that has a normal vector? Are we saying that?
If we have two vectors which are in the plane, then the vector that is orthogonal to both of them must be the normal vector for that plane.
Right. And so if you take two vectors in a plane and you take their cross product, which we literally just did, that normal vector is normal to the plane that contains those vectors. So because, I suppose we could write more words here saying something to the effect of like, because the plane pi contains the two vectors we just found, PQ and PR, and because their cross product is exactly the right normal vector. That's usually how we find, like, if instead he asked you to find the equation of the plane, which is another way you could have gone about doing this, right? You could have just said, well, I'm just going to go through the process of finding the equation of the plane. And I know that the plane containing P, Q, and R is the plane with normal vector PQ cross PR. And it has to contain one of those points. So for example, you could say, well, I know it's going to be the plane who, well, okay, if you really want to get into it, we could say the following. So this vector, which we just found, is -3, -21. Where'd you go? -3. So that vector is normal to our plane. And then what you could say is, well, pick any point in your plane. Not one of the ones we've already talked about. And one of the points we've already talked about. Let's say P, which is 1, 0, 0. This vector from 1, 0, 0 to x, y, z, and this normal vector have to be orthogonal. Any vector in the plane has to be orthogonal to the normal vector. So what we can do is we say, okay, well, this vector, let's call it V. V equal to x minus 1, comma, y minus 0, comma, z minus 0 must be perpendicular or orthogonal to n equal to -3, -21, -3. Okay, but what's the true thing about perpendicular vectors? The thing we often use is that their dot product has to equal 0. So if we take the dot product of V and N, which is literally just the components multiplied together. So it's going to be, I should have written it as N dot V. It doesn't really matter, but I want to write these things first. It's going to be -3 times x minus 1 plus -21 times y minus 0 plus -3 times z minus 0. That dot product has to equal 0 because those vectors have to be orthogonal to each other. But then check this out. We end up getting -3x plus 3 minus 21y minus 3z equal to 0, or -3x minus 21y minus 3z equals -3, which I believe was exactly the equation that we were trying to show was the equation of the plane. So that's actually how you can go about finding, if you have to find the equation of the plane based on having 3 points in the plane. Other questions about this one? Okay. We can definitely come back to that if we need to. Let's look at the next question. Justify that the vector, which he didn't write in the usual vector notation, but we'll find whatever. This vector is a direction of the line of intersection of the plane pi that we just talked about with this other plane here. So reminder, the plane pi, right, is given by the equation negative 3x minus 21y minus 3z equal to negative 3. Oh, and he's giving you this other plane here, and capital pi is the plane x plus z equal to 1. So if you want to find the line of intersection of two planes, you have to take the cross product of their normal vectors and then find a point that's on that line. Actually, well, if we just want to find the direction, you just need the cross product of it. So the direction of the line L is just going to be the cross product of the normal vector for the plane little pi crossed with the normal vector for the plane big pi. Sorry, my little pi, my big pi do not look that different. I apologize. Well, great. We can find those because that's just going to be the normal vector for this, which is negative 3, negative 21, negative 3, crossed with the normal vector for this plane here. Now we have to be a little extra careful here. The coefficients of x, y, and z are 1, 0, and 1. So we need to make sure we get the 0. And then crossing those vectors together, well, again, it's another determinant. We got I, j, k, negative 3, negative 21, negative 3, 1, 0, 1. So that's going to equal I times negative 21, negative 3, 0, 1, minus j times negative 3, 1, 1, plus k times negative 3, negative 21, 1, 0. If we calculate this, we've got I times negative 21. Oh, sure, that'll be fine. If 21 times I minus j times negative 3 minus negative 3, which is 0, plus k times 0 minus minus 21 is plus k times 21. So we're getting the vector negative 21i plus 0j plus 21k. But that vector and that vector are in the same direction. They're just pointing opposite directions, but we don't care if it's the opposite direction. If we really wanted to get it, we could cross them in the other direction, but this is good enough. This is definitely in the same direction as v. Cool. All right, distance from a point to a line. So the line L, ooh, what is the line L? So now he's at, so this is kind of, I mean, not tricky, but we have the direction now for L. Now we have to find the equation of the line L by finding a point on the line. So really we have to find a point on the intersection of this plane and that plane. It's kind of annoying. Here's how you do it. You set one of the things equal to 0. And if it doesn't work, then you pick something else. So for example, I'm definitely not going to, setting y equal to 0 seems dicey. I'm going to set z equal to 0 and see what happens. So z equals 0 for these two planes. Well, over here, I have to get x equal to 1. So for big pi, I get x equal to 1. And for little pi, I need to also get x equal to 1. So if x equals 1, then I've got negative 3 times 1 minus 21 times y minus 3 times 0 equal to negative 3. Let's see. So I've got negative 3 minus 21y equals negative 3. So negative 21y has to equal 0. I feel like this is one that's going to work out no matter what you pick, kind of, because the not having a y here means y can be anything. So we're going to get y equal to 0. So our point of intersection is z equal to 0, x equal to 1, y equal to 0. So this point, 1, 0, 0, is on the line L, the line of intersection between between the two planes. Because to find the distance between a line and a point not on the line, you have to know a point on the line. And at this point, before we did that, we only knew what the vector was in the direction of the line. So you don't have to draw this picture, but I kind of like drawing the picture. Here's my line L. I know the vector on the line L is the vector v. You can either use the one we found, which is -21i plus 21k, or the one here, which is 21, -21. Either one is fine. I'm gonna use the one he gave me, which is 21, 0, -21. And then you've got this point here being 1, 0, 0. And then this other point not on the line being, sorry, 0, 0, 2. So what we're going to do, here's what I've kind of gotten down to knowing about this. For point to a line, it's always going to be cross product. For point to a plane, it's always going to be dot product. So here, to go from this point, sorry, to find this distance here, d, that distance d is going to be the cross product of these two vectors. So ps crossed with v, magnitude of that, divided by the magnitude of the vector v. Seems really kind of annoying to have to calculate, but here we are. So there's another, oh, this is not a terrible cross product though, right? Because the vector ps and the vector v are not too terrible. So let's do that over here. So ps crossed with v is going to be, got I, j, k again. ps is the vector 0, -1, 0, -0, 2, -0, and v is the vector 21, 0, -1. Now here's the thing. Instead of using 21, 0, -21, we could use any multiple of that. So maybe instead of using this, I might use the vector 1, 0, -1. Those vectors still point in the same direction. It's a totally fine choice to make. It's a totally valid choice to make. We just have to remember that if that's the vector we're using, then that's the magnitude that we're going to end up dividing by over here. So then if we do this, we are going to get I times, okay, 0 minus 0 minus j times -1 times -1 minus 2 times 1 plus k times 0 minus 0. So you end up just getting negative j times -1, so you just get the vector j. Interesting. So then what's the magnitude of the vector j? Yeah, just 1. So we're going to end up getting 1 divided by the magnitude of the vector v, which is the square root of 1 squared plus 1 squared. So there's your distance. This would have come out the same if we'd used 21 here and -21 here. We just would have had to divide by something grosser. We would have had like 21 divided by the square root of 2 times 21 or something like that, or the square root of 2 times 21 squared, which would have been gross. All right. Distance from a point to a plane, a little bit easier in my mind, to be honest. So point to a plane. I still want to draw myself a little picture. So here's my point S. Here's my plane pi. I do need a point in the plane. So I go back to my plane equation. I'm picking the easiest thing I can. I'm going to pick 1, 0, 0, which I already knew was a point. I guess I'm technically picking the same point that happens to be on the line. I could have, yeah, I might as well just use this point here because it's already on the line of intersection, which means it has to be in the plane. So here's our point. Interesting. It feels like it should be the same. Let's find out if it is. But let's think about this for a second. If this plane contains the line of intersection L, then the distance from this point to that point there, or I should say distance from this point to the line that is contained by the plane should end up being the same. Let's do the work. So in this case, the way you typically find it is you do the normal vector to the plane dotted with your vector PS divided by the magnitude of your normal vector. And then it's the absolute value of that top part there. All right, the normal vector to the plane is -3, -21, -3. Oh yeah, question. Oh, you can't see it? Yeah, sorry. So we're going to get -3, -21, -3. dotted with the vector PS, which is again, -1, 0, 2. And we'll put some absolute values around that. Divided by the magnitude of the normal vector n, that's terrible. Which is going to be, yeah. I suppose I could have reduced this down as well, but I didn't, so it's too late. This will be the square root of -3 squared plus -21 squared plus -3 squared, which is 9, plus 21 squared, which is 441. I'm not confident, but we'll see what happens here. So if we dot out this top part, we get -3 times -1, which is 3. And then -3 times 2, which is -6. So we get 3 minus 6 in absolute value over the square root of, this looks way different, 440, 450, 459. So that's going to be 3 over the square root of 459, which seems very different.
It's like the closest point on the plane isn't necessarily going to be on that specific line. It could be on some other line.
Sure. Yeah. Okay. Good point. Yeah. Yeah. It's hard for me to see that, but I get it. Yeah. Which certainly, this is definitely much smaller than that. Thank you, Patrick. I was having a hard time seeing that. That makes a lot of sense. Good. I was hopeful because I was like, oh, if we could have just done this part and not done that first part, but no, we're stuck. Yeah. Yeah. Good point. Does that make sense to both of you? That there could be a different point on the plane that is way closer to our point out in space? Yeah, that makes sense. Yeah. So maybe like your line's there and your plane's here, and like your point is like sitting right here. So the closest point to the plane is right down there, or the closest point to the line, or the distance to the line is way over there. It's a much larger distance. Yeah, good. Thank you. Sorry, Caleb, you can't see that, but it makes sense. All right, so let's look at the next one here. Moving on to a new question. Consider the vectors u and v. Show that this vector 4, 7, 8 is perpendicular to both. Okay, the easiest way to do this would just be to dot that new vector with each of u and v. So if I want to show something's perpendicular to two other things, I'm usually just going to take dot products. So I'm going to call this w for a second and say, okay, great. Well, u dot w is 2, 0, -1, dotted with 4, 7, 8, which ends up being 8 plus 0 plus -8, which is 0. And v dot w is equal to 3, 4, -5, dotted with 4, 7, 8. That's going to be 3 times 4 plus 4 times 7 plus -5 times 40. Sorry, -5 times 8, which is -40, which is also 0. And that shows it, right? We know that if u dot w is equal to 0, then they're perpendicular. You might write that down. U dot w equal to 0 shows u and w are perpendicular. And the same thing for v dot w. Argue that u is not parallel to v. I can do this in two ways. One way is I would say, well, u is not a multiple of the vector v. For vectors to be parallel to each other, they have to be multiples of each other. Alternatively, I could do part C of this question. Part C, so this is where it sometimes pays to read ahead. If I look at part C, it says, compute sine of theta, where theta is the angle between u and v. Well, if the angle between u and v isn't 0, then those vectors aren't parallel to each other. So you could say u is not a multiple of v, or you could say C part C. The angle between u and v, which we're about to find, is definitely not 0 degrees or 180 degrees. It's the only way that vectors can really be parallel to each other. Let's actually find it. So let's see. Computing sine of theta seems like an interesting question. That's not something we usually calculate, right? Usually we're calculating yeah, of course. Sorry. Usually we're calculating cosine of theta, which is what I would still start with, actually. So I would say, well, I know that cosine of the angle between U and V is equal to U dot V divided by the magnitude of U times the magnitude of V. Okay, so U is 2, 0, -1, dotted with V, which is 3, 4, -5, divided by their magnitude multiplied together. So the magnitude of U is the square root of 4 plus 0 plus 1. And the magnitude of V is the square root of 9 plus 16 plus 25. So we end up getting the dot product here, which is 2 times 3 plus 0 times 4 plus -1 times -5. So 6 plus 5 on top. And the bottom is the square root of 5 times, let's see, 9 plus 16 plus 25 is the square root of 50. You get the square root of 5 times 50, which is 250. Interesting. So this ends up equaling 11 over the square root of 250. Now, technically, you could say, well, then theta equals the inverse cosine of 11 over root 250, and sine of theta is just sine of inverse cosine of that. I don't think that's what you're intended to do. But if you were really stuck, you could go that way. So if you're stuck, you could say, great, theta equals the inverse cosine of 11 over root 250. And then sine of theta is equal to sine of that gross thing there, sine of inverse cosine of 11 over square root of 250. What I think you were actually meant to do is to say, well, great, I can draw a triangle where cosine is equal to the adjacent over the hypotenuse. So cosine theta is equal to adjacent over hypotenuse. And then I can find the third missing side of that triangle. So if I call this y, I've got 11 squared plus y squared equals the square root of 250 squared. Then y squared equals 250 minus 11 squared, which is 121. And 250 minus 121 is 129. So y is going to be, I like this question. This is a good question. This would have been a better, this would have been, there's a way we could have made this question just a little bit more interesting, which I'll say, let's talk about it. So here, y is equal to plus or minus the square root of 129. So then sine of theta is going to be y over root 250. Let me ask you, based on all the work we've done, specifically looking at the dot product, should sine be positive or should sine be negative? Does it actually matter? Could sine ever be negative? Let me back it up. Let me ask a slightly different question. When you're finding the angle between two vectors, we typically describe it as being an angle between 0 degrees and how many degrees? Right. And between 0 degrees and 180, we're in quadrants 1 and 2, and sine is always positive in quadrants 1 and 2. So we're never going to get a negative here. It's always going to be the positive part. So here, sine of theta should be the square root of 129 over the square root of 250. Which for sure shows that these vectors are not parallel to each other, because if they're parallel, sine of theta would have to equal 0. Because sine of 0 degrees is 0 and sine of 180 degrees. Or if you like, sine of 0 is 0 and sine of pi is 0. Yep. We don't have one. That's not okay. That's not entirely true. My brain just didn't think of it that way. You are right. You totally could have done this a different way. So technically we do have an equation involving sine theta. I just kind of forgot about it because really, I'll be honest, I never think of that equation. It's just not the one in my brain. But we could have said, oh yeah, I guess U cross V is equal to the magnitude of U times the magnitude of V times sine of theta times the normal vector, the unit normal vector. And then if you take the magnitude of both sides, you get the magnitude of U cross V equal to the magnitude of u times the magnitude of v times sine of theta. And then the magnitude of the unit vector there is just 1. So I guess, yeah, you're right. I really like, it's not what I ever want to do. Sine theta is the magnitude of u cross v divided by the magnitude of u times the magnitude of v.
Like, you can get that far, but you can't really get data out of that very easily.
Right, but again, we're not being asked to find theta, right? Right. Right, because then in that case, you wouldn't know if it was acute or obtuse, because yeah. But let's do it, because we might as well see it the other way. Just let's see if the way we did it would have worked, or if we did something totally wrong. I think we're right, but let's just make sure. So we do it this way. Our u vector is, it's going to be. Also, I would say I think doing it the other way, in my opinion, might still be easier, because usually taking a cross product for me is just more work. We take the cross product of u and v. We're going to get I times minus j times plus k times 2, 0, 3, 4. Sorry, I'm not messing all the words. So I'm getting 0 minus 4, so 4i, and then 10 minus 3, so minus 13j, and then 8 minus 0, so plus 8k. Let's double check that. 0 minus 4. Yep. 10 minus 3. Yep. Okay. 8 minus 0. So then the magnitude of u cross v is going to be the square root of 4 squared plus 13 squared, which is 169, 8 squared, which is 64, all divided by the magnitude of u and times the magnitude of u, which we did calculate in the previous problem. So I should just look back there. The magnitude of u was, did I calculate it? Yeah. Square root of 5 times the square root of 250 times the square root of 50. And I guess it's not that hard to calculate. It seems like it's going to be different. Question, Patrick? Did I make a mistake? 2, 0, negative 1. Oh, I missed, I missed the negative 5. That should be 3, 4, negative 5. Good. That was because things were looking like they were going to be wrong. So I was getting kind of worried for a second. So that should have been a negative 5 there, which doesn't change anything. But a negative 5 there does change stuff. That's negative 10 minus negative 3, which is negative 7, which is going to be minus negative 7. So really, good job, James. So that's 4i plus 7j plus 8k. Negative 10 minus 3. Yep. So really we should have, instead of on the top, we should have that we're getting the magnitude of u cross v over the magnitude of u times the magnitude of v should be, let's see here. So we're getting the square root of 4 squared plus 7 squared plus 64, all divided by the square root of 5 times the square root of 50. And let's see, 16 plus 64 is 80, and 80 plus 49 is 129, the same thing we got the other way. Cool. So either way will work. And either way will work, yeah. That's all I really say. I guess my brain defaults to avoiding the cross product if I can. It feels like more work to me, but that doesn't mean you can't do it that way, obviously. All right, a couple more questions here. Verify that the vector W is equal to 1, 0, 2 is perpendicular to U, but not perpendicular to V. Again, showing things are perpendicular or not is pretty straightforward. If I'm trying to show that this is perpendicular to U, I'm just going to show that W dotted with V is equal to 0. And it is, right? W dotted with V is just going to be 1, 0, 2 dotted with 2, 0, negative 1. And then on the other hand, W is not perpendicular. Oh, sorry, that was with U. I apologize. I wrote V instead of U. Sorry. And then W dotted with V is not 0. That shows that they're not perpendicular. And we can see that's going to be true because W dot V is going to be W 1, 0, 2 dotted with V, which was the vector 3, 4, negative 5. And that's going to be 3, plus 0 minus 10, which is -7. It's clearly not 0. And I really think that's all you have to do there, right? I think your teacher should be totally fine with you being like, yeah, dot product is 0 means perpendicular, dot product is not 0 means not. And finally, find a vector that is perpendicular to V, but not perpendicular to U. So here's U equaling 1, 0, 2, and here's V equaling 3, 4, -5. So I'm going to go easy. I'm going to pick something, let's call it, I don't know, R. So I'm just going to pick these two and say 4, -3 will make the dot product of those parts 0, and then just slap on a 0 at the end. And then check to see if it works to be not perpendicular to U. It shouldn't be, but if we check here, let's see, 4 times 1 plus -3 times 0 plus 2 times 0. Yep. U dot R is definitely not 0, and V dot R definitely is 0. But really, if you're trying to come up with a vector, you can kind of just make one up, and odds are it will, as long as you make it perpendicular to this one, it's probably not going to be perpendicular to that one. And then if it happens to be, just try again with different conditions. Okay. The next one. Some particle motion here with trajectory r of t equal to cosine of t plus sine of 4t plus t cubed. Interesting. We have a cosine and sine with different inputs. So here's what I would observe right off the bat here. I would point out that cosine squared plus sine squared does not equal 1 here. Or I should really say cosine squared of 3t plus sine squared of 4t not equal to 1, because they have different arguments. They have to have the same argument for that trigonometry to be true. So first question though, this is asking where is it going to be when time equals pi? So r of pi, we're literally just plugging in pi and getting cosine of 3 pi, comma, sine of 4 pi, comma, pi cubed. And even though he wants you to simplify, if you're low on time, leave it as is. Come back if you have time to simplify that. We can simplify that. Cosine of 3 pi is going to be -1, sine of 4 pi is going to be 0, and pi cubed is pi cubed. So that's where the particle is at time equal to. And then they want us to find the velocity vector. So that's just taking some derivatives. So v of t is going to be, well, the derivative of cosine of 3t is going to be negative sine of 3t times 3, or -3 sine of 3t. Well, this is going to work out nice. The derivative of sine of 4t is going to be 4 times cosine of 4t. And the derivative of t cubed is going to be 3t squared. And then he asks us to compute the speed of the particle at t equal to pi. So first we're going to find the magnitude of the velocity vector. So speed is equal to the magnitude of velocity. So that's going to be the square root of -3 sine of 3t squared plus 4 times cosine of 4t squared plus 3t squared. You could probably skip writing the things squared and just actually square them, right? This is the square root of 9 sine squared of 3t plus 16 cosine squared of 4t plus 9t to the 4th. And then if we plug in pi, the magnitude of v of pi is going to be, all right, so let's be smart about this. Sine of 3 times pi is going to be 0, because sine of any multiple of pi is 0. Cosine of 4 times pi is going to be +1. It doesn't actually matter if it's positive or -1, because we're going to square it anyway. What we're going to get here is we're going to get the square root of 0 plus 16 times 1 plus 9 times pi to the 4th, which is interesting. 16 plus 9 pi to the 4th. And there is not any nice way of simplifying that. It just is what it is. Kind of gross. But it is. That's what we get. I really think this question is mostly just about, do you know what the things are? Do you know that velocity is the derivative position? Do you know that speed is the magnitude of velocity?
When we're calculating the magnitude, it's always just like doing the square root and then squaring it.
Right, so the square root of the sum of each component squared for any kind of vector, whether it's one like this or ones like the ones you were doing before. All right, and then show that the acceleration at t equal to pi is given by this vector here. Okay, well, acceleration is just the derivative of velocity. So here's our velocity vector up here. Let's take its derivative. So a of t is going to be the derivative of this, which is going to be -3 times cosine of 3t times another 3, and -9 times cosine of 3t. And then the derivative of 4 cosine of 4t is going to be -16 sine of 4t. Finally, the derivative of 3t squared is going to be 6t. And then if we plug in pi, we should get exactly what they're hoping that we get. We get -9 times cosine of 3 pi, excuse me, which is -1. -16 times sine of 4 pi, which is just 0, and 6 times pi, which is equal to -9 times -1, comma 0, comma 6 pi. As expected. Then there's this last question here. Will there ever be a positive time t where the particle will be at rest, i.e. have 0 speed? Well, let's go look back at the speed. So the speed, which was just equal to the magnitude of the velocity, was equal to the square root of, and I'm going to write this, the most simplified version of this, 9 sine squared of 3t plus 16 cosine squared of 4t plus 9t to the 4th. Now the question is, will that ever equal 0? I should say equal 0. It actually doesn't matter if t is positive or negative, honestly. But I would say certainly not. And the reason why not is because, well, 9t to the 4th is greater than or equal to 0 for all positive t. I should really say actually strictly greater than 0, right? There's not an equals there, because if t is strictly positive, then 9t to the 4th is strictly positive. Similarly, 9 sine squared of 3t is going to be always greater than or equal to 0. And 16 cosine squared of 4t will always also be greater than or equal to 0. And so if you add these things all together, it's going to be greater than, strictly greater than 0. So 9 sine squared of 3t plus 16 cosine squared of 4t plus 9t to the 4th is strictly greater than 0 for any positive t. So it can't equal 0. So the magnitude of velocity cannot equal 0 for any t that is positive. And probably not for any t at all, but it's easier to argue for t being strictly positive, because then you can say that this has to be strictly positive. Where if t was equal to 0, then you'd like have to check, well, if t is 0, this could be 0. Maybe both of these happen to be 0 too. It's not, but right. But cosine, exactly. I think he was trying to make it a little easier for you to not have to also write that right there. All right, and then we've got, this last page is a bunch of circle the right answer questions. We got time, So for each of the statements below, circle the unique correct answer. You do not need to justify your answer. Okay, so the intersection of a sphere with a plane. I should say with this plane. So the thing is, it could be it could be 3 different possible things. It could be a point if the plane is tangent to the sphere. It could be a circle if it normally like cuts the sphere, or it could be empty if they don't actually intersect each other. So how do we know? Well, I'm going to look at the center of this circle. So the center, sphere. So the center here is 2, 0, -1, and the radius is 4. And then this, like, this, how, like, I'm trying to think about how I would really have an idea if these cut each other or not. I might skip that one and come back to it because I don't really know, like, do these planes really, does this plane cut that circle? Well, let's see if I plug in 2, 0. That's nice. So if you plug in, if you happen to think to plug in the center here, if I plug in 2, 0, -1, I get 4 minus 0 minus 5, and it's equal to -1. So the center of this sphere happens to be a point on the plane, which means the plane has to actually cut the sphere. It's cutting it in a circle. Oh, thank you. So I would actually point out it's technically it's not a sphere, it's the ball, right? Because if we're talking about everything inside the ball. So you're right, good point. It's not cutting it in a circle, it's cutting it in a disc. That's tricky. I would have totally missed that. But I would point out, I would have missed that, but I feel like technically this is a misleading question because you shouldn't be using the word sphere here along with this equation, because this equation is not a sphere. This is a ball. I should say this inequality is not a sphere. It's a ball. Right. Just like, so the circle, so a circle is this, right? Sorry, that's a circle. And this is the equation x minus 2 squared plus y minus 1 squared equal to 9. Circle. Here's a disk. X minus 2 squared plus y minus 1 squared less than or equal to 9. There's your disk. So the circle is the boundary. The disk is everything inside and also including the boundary. In a similar way, we say a sphere is the boundary and the ball is the entire interior as well as the boundary. It includes all of the interior points, which is, I don't love the word ball for that personally, because when I think of a ball, I typically think of like a beach ball, which is still hollow. You could think of something more solid, like, I don't know, a softball maybe, because that's kind of got an interior, but like ball to me doesn't really indicate what I want it to indicate. So yeah, I would actually maybe ask for clarification with him because I think he's used the incorrect word here. Right, exactly. But the problem is the word sphere indicates the hollowness, but the equation, or actually inequality here, indicates being full. So I would definitely clarify with him because those are not matching up in my brain. Let's see, look at the next one. The intersection of this plane with that plane. Okay. Okay. So, right, they've made it easy. These planes are definitely parallel. They could be the same plane though. So we have to double check just to make sure that they don't contain the same point. So this plane contains the point 1, 0, 0. This plane does not contain the point 1, 0, 0. So we're good to go. They're parallel. So they're empty. What? Right, exactly. It's like the floor and the ceiling. I will also point out there's only one other possible answer here. It couldn't be a circle. It couldn't be a point. It couldn't be 2 points. The only other possible answer is the planes intersect in a line. So actually, I didn't even need to check that they contained a common point because the only other possible answer, if we know the planes are parallel, is that they actually coincide with each other. So they would intersect in a plane if they coincided. Okay. The cross product of these two vectors is, let's see. So let me ask, do these two vectors have anything interesting in common with each other? Are they parallel? Yeah, they are parallel. And parallel vectors have a cross product that is the 0 vector. We could do the math, but we don't have the time though. But if you do, so if you actually take the cross product of these two vectors, you will get 0i plus 0j plus 0k. And parallel, so just like perpendicular vectors always have a 0 dot product, parallel vectors always have a zero cross product, which makes sense if you think back to that sine cosine question, right? If two vectors are parallel, sorry, if two vectors are perpendicular, then cosine of them should equal 0 because their angle between them is pi over 2. If two vectors are parallel, then sine of them should equal 0, which means the angle between them is 0. Midpoint, okay, midpoint should be not hard. It's halfway between each. So it's half of 0 plus 8, half of 6 plus 2, half of 4 plus -4. So it's going to be the point 4, 4, 0. And finally, a particle with this trajectory has speed at t equals 0. So we know how to calculate speed, right? It's going to be the, okay, fine. The velocity is e to the t, comma 1, comma 5. And then the magnitude of that is going to be at 0 is going to be just the square root of e to the 0 squared plus 1 squared plus 5 squared, which is the square root of 27. So, right, exactly. The thing here, right, is it's not that none of these are doable, it's that you have a limited amount of time. So that's why I'm not trying, right, especially these where they say you don't have to justify your answer. I'm trying to do as little work as possible. So we're looking for things like, are these things parallel? Or, yeah. I feel like this first question would have been a lot harder if the plane and the sphere didn't intersect. Because it's, in my opinion, it's hard to kind of tell whether or not that's true. So I do think it's a good idea. I think it was intentional that the center of the sphere was a point on the plane. So I would certainly look for something like that if this kind of question is on your exam. Yep, I did e to the 0. Right.
Could you go back to
Totally. So again, they're asked, the question is there ever a positive value of t where the particle will be at rest? That is, have 0 speed. Well, it's not a polynomial, right? Because you've got sine and cosine. But I was just saying that since basically everything is being raised to an even power, right? What I really have here is I have, well, essentially, right? The only way of saying it as well. The only way for speed to equal 0 is if each component is equal to 0, because you're going to square each component. So really, the only way for speed to equal 0 is if your velocity vector is actually the 0 vector. And the only way for the velocity vector to equal the 0 vector is for each component to be 0. But there isn't a way that component can be 0, right? 9t to the 4th can't equal 0 if t is strictly positive. Well, that can equal 0, though, right? Sine can equal 0 for lots of different values of t. Right, they can't all be 0 at the same time. But again, we're not having to, while we could show that, we're not trying to work that, right? That's definitely, like if they had said for any time t, then yes, we would have had to be a little bit more general. But I think they were trying to give us an easy out here and say, well, since we're specifically saying that time is positive, not 0, not negative, then since time is greater than 0, this term can never be 0, and you can never get the 0 vector. Sure, yeah. But the kind of thing that's important here, or that's helping us do it, is the fact that everything's kind of being raised to an even power, which is always going to be the case if you're finding the magnitude of the vector, because each component is getting squared. I guess you could have something not like that. If you had like a t to the 3/2 being squared, then you'd have a t cubed, and maybe you could have something negative. Although even then, no, you really can't. It's still got to be positive, because the way you're taking like -1 to the 3/2 ends up being -1, but then you square it. Is it going to be -1? Can you take -1 to the 3/2? No, you can't. It's not even in the domain, so it's not allowed. So yeah. All right. Good luck on your midterm. Patrick, good luck on yours too, but I'll see you before your next one. I assume I will see you. If I don't, that's also fine.